In this SPSS lesson, I want to show you how to run the t-test for independent groups on a data set, and more generally just to analyze that type of design, a two-group design where we have a numeric dependent variable. So the data set we want to read in is in the form of a text file. Here's what it looks like. So it's an unformatted text file, but it's in what's called comma-separated values, or .csv format. So here on the first line of the data file, I have the variable names. That's sometimes you do that, sometimes you don't, but it's very convenient. So the first variable is a grouping variable, and it defines two groups. An experimental group, let's say these are students who experienced an experimental curriculum for teaching signed arithmetic with integers, and then another group of students who received a control curriculum, or the traditional curriculum for teaching that topic. The next variable is test score, given at the end of the course, or the end of the course section. And those values, again, 20.5 to 25.0 and so forth, are set off by commas. The third variable is called pass. That's just an indicator variable that's equal to 1 if the student score is greater than or equal to 20, and equal to 0 if it's less than 20. Let's say that's the cutoff for mastery of the topic. All right, let's minimize this and read it into SPSS. So we'll go File, Open, Data. And it will take me back to the directory where I was working previously. But this is not the file I want, because this is in .sav format. That's an SPSS save file, data file. So let's instead look for files of type CSV. Here's the file we were just looking at. The icon says it's an Excel file because Excel is willing to read in .csv files and save such files. So that's the association on my computer. And anyway, so let's just double-click on that file. And SPSS tries to read it in. So here's its preliminary view of that file. That looks right. Does our text file match a predefined format that I have stored somewhere? No. Let's go next. How are your variables arranged? Well, they're delimited by a specific character. Again, there are commas in between the fields on each line. Are variable names included at the top of your file? Yes, and that's on line number 1. Decimals are represented by a period, like 12.42. That's standard in the US. So the first line of data begins on line number 2, because line 1 had the variable names. How are your cases represented? Each line represents a case, and I want all of the cases. So we go next. Which delimiters appear between variables? Well, comma. When it reads in a .csv file, it knows that's the default. And here's its preliminary preview of how it's going to read in the data, and that all looks fine to me. Looks like everything is lined up and read correctly, so I'll go next. And now what it's going to offer me is the chance to go in and define the type of each variable. Is it numeric? Is it categorical? And so forth. But I'm going to let SPSS do its best figuring that out. Again, data still looks fine in the preview. Do we want to save the format of the data file, reading in and paste the syntax? No. We just want it to finish. Okay, so it looks like it's fed the data in correctly. And furthermore, from these little icons here with the variable names, I can tell that it's even defined the type of the variable correctly. Like the grouping variable is called a string variable. That means it has character data in the field, like EXP rather than numbers. And its level of measurement is defined as nominal. Great. Okay, this little ruler means that score is defined as a numeric variable, and it's of type scale. Scale means it's of interval or ratio type level of measurement. And then finally, pass is defined as numeric. That's correct because the values are 0, 1, but it's defined as nominal level, which is fine because, again, for a dichotomous variable, we can't really tell its measurement level. It does define two categories, pass and not pass. All right, so the data is read in correctly, so let's proceed to analyze it. But, so there are a couple of things we could do. I could go analyze descriptive compare means, and just to generate descriptive statistics on each group. So it would compute the mean and standard deviation of each group. But I don't want to bother to do that. Instead, what I'm going to do is proceed directly to the t-test, because that will give us the descriptive statistics automatically. And before I do that, we're going to compare. We're going to look at. So remember, one of the distributions of the t-test for independent groups is that score is supposed to be normally distributed within the experimental group, and also normally distributed within the control group. A few more cases at the bottom I'm not highlighting. So if we want one good method or type of graph for comparing the distribution of a variable in two groups is a box plot of a numeric variable. We just want a simple box plot define. So the grouping variable will define the categories. Score, the numeric dependent variable, will go in the variable field. Now it says we can go OK. By the way, you notice that in the graph software that I went to the menu item called Legacy Dialogues. And that's because, frankly, those are a lot easier to use than the more recent menu system. And here we see the box plots we want. So this one shows a representation of the distribution of score in the experimental group. You can see that the median is higher than the median for the control group here, as are Q3 and Q1. You can also see that in general there seems to be more spread or dispersion in the experimental group. And in the control group, it seems there's an outlier, somebody with a really quite low score. Okay, so that tells us a lot about the distribution. Let's go ahead and conduct the t-test now. So to do that, we want to go down, Analyze, Compare Means, and over here we'll see the Independent Samples t-test. Analyze, Compare Means, Independent Samples t-test. So let's click on that. And now we'll define score as the testing or dependent variable. Group is the grouping variable. Oh, we got some question marks there. That's because it wants me to define the groups, the two groups I want to compare. So as you recall, on the grouping variable, the experimental group is designated by the letters EXP, and the capital is important because that's how the data looks, and CON. Okay, so that's what defines group 1 and group 2, and I'm defining group 1 to be the experimental group. Continue. Okay, this looks good. Let's just go to options, see what options we have. It's also going to give us the 95% confidence interval. That's good. Let's just go OK. I think we're good. And here, indeed, we see the results of the t-test for independent groups. So first off, it gives us the descriptive statistics. It tells us the mean for the experimental group is 21.82. The mean for the control group is 19.37. And the standard deviations, the standard deviations are a bit different. So as we know, that's problematic for the independent groups t-test. But our rule of thumb is we won't worry about that unless the ratio of the two standard deviations gets to be more than 2 to 1. It's getting close to that here, so this may be a problem. So down here now we see the results of the independent samples test. So the first two columns, don't be confused, are actually a test for equality of variances. So again, if this test is significant, that is the p-value here in the sig column is less than 0.05, we would say the Levene's test is significant, and that means that the variances in those two groups are unequal. Here the test is not significant, so we don't have strong evidence that that assumption of equal variances in the two groups is violated. So we could proceed to the t-test. And there are two versions of the t-test given. One is in which we make that assumption of equal variances, which seems kind of okay given this test result. But if you don't feel comfortable doing that because you feel these are too different, you could use the unequal variances version of the test. But in any case, what do we get? Well, let's just go with the equal variances version because that's what we learned to do by hand. So the value of t is 2.67 or 2.668. Degrees of freedom is 20. What is that? That's n1 plus n2 minus 2. And the significance value is 0.015 because that's the p-value. Because the p-value is less than 0.05, we say that t is significant, and there is a significant difference in means between the two groups. And it's reassuring to note that we get the same result whether we assume equal variances or not. And then it also will give us the information on the confidence interval. It'll give us the raw difference between the two groups in means, which can be thought of as a measure of effect size, right? The experimental treatment seems to lead to about a 2.5 advantage in test score compared to the control group. And then it uses the standard error of the difference to give us the lower bound and upper bound for the 95% confidence interval. Okay, so this is a good way to run the t-test, especially for large samples where you don't want to do it by hand or compute the descriptive statistics by hand. So we could write this up as establishing that the difference between experimental and control means of the test score variable is significant, and therefore we can conclude there is a true difference in the population means of experimental and control population.